Bioluminescence, the living light. In this report I'll talk to you about how bioluminescence works, its uses, as well as its history. Almost to my dismay, I looked at the assignments related to bioluminescence, and I see that much of this information has already been covered. The script is already written, so oh well. Moving on, history. A French pharmacologist by the name of Raphael Dubois is credited with early work in bioluminescence. However, the first discovery of bioluminescence, as far as we know, dates back to the days of Aristotle, where he described 180 marine organisms that seem to have bioluminescence. The Greeks also referenced the glow in the sea. Now, while doing research, I couldn't help but notice that many people refer to this as phosphorescence. This is false. However, phosphorescence by definition is light emitted by a substance without combustion or precipitable heat. This is very similar to the definition of bioluminescence, and there are others like crystalloluminescence, radioluminescence, sonoluminescence, thermoluminescence, chemiluminescence, mecholuminescence, photoluminescence, and electroluminescence. Then of course there are these subcategories like phosphorescence, fluorescence, triboluminescence, fractoluminescence, piezoluminescence, cathodoluminescence, electrochemiluminescence, and of course bioluminescence. These are all types of cold light accompanied with little or no heat, or in luminescence. Seeing this information, you might be thinking, well, no duh. But I couldn't help while looking over the internets, I saw people getting confused about this, so I just wanted to clear it up. Bioluminescence is a form of chemiluminescence, which is a form of luminescence, and that is the reason where you see these glowing waves, not phosphorescence. There are others who have commented on this before we even knew fully what it really was. Christopher Columbus, who referred to the mysterious lights below the ocean, Shakespeare, who commented on the glowworm in Hamlet, and Robert Boyle, who took a more scientific approach to it and commented on the air required for it, and so many others. How it works. Bioluminescence at its basic level is composed of two parts, luciferin and luciferase, light bringer and light bearer. Luciferin acts as the pigment part of bioluminescence. It reacts with oxygen to produce light, while luciferase acts as an enzyme to speed up the process. Luciferin reacts with oxygen to create a compound called oxyluciferin. This process is very slow, however. This is where the luciferase comes in to speed up the process. The aim results in oxyluciferin coming out of the reaction in an electronically excited state as a photon of light and heat. Speaking of the heat, to give you an idea of the efficiency of bioluminescence, I want you to look at these two pictures. This light bulb produces 10% light and 90% heat, not the most efficient. However, in this firefly, about 80 to 90% of the energy comes out as light, and 10 to 20% is heat. Hence the name, cold light. Now let's talk a bit about the different colors. There are several theories on why, which colors are which in the realm of bioluminescence, but at the very basic level it depends on the structure of the luciferase and the luciferin. I believe now is the time, if you don't already know, there's more than one combination. There are dozens and dozens of different combinations of the two molecules. Most of them we're not even beginning to understand or comprehend. The ones that we do understand to a point could possibly take hours to explain in detail. So from now in the video, we'll stick to what we do know. Bioluminescence is caused by a luciferin protein and a luciferase enzyme. These react with oxygen, which in a chemical reaction produces an excited oxyluciferin coming out as a photon of light and a small bit of heat. Oh, and the subreaction that could possibly happen that I haven't mentioned until now. All this to say, getting deep into bioluminescence can be hard. Why they do it and its uses. Let's take a more well-known example of a bioluminescent creature, the anglerfish. These fish look like they have light bulbs on top of the stems of their heads, which is actually called the esca. Now before we start making fun of the fish for being stupid and gullible for blindly swimming into an ominous shiny thing, let me remind you that humans too also do stupid things for shiny things, like steal and fight and kill and start wars and global conflict in exchange for said shiny things. So don't bash poor Marlin, he has enough to deal with right now. You may or may not know about the dragonfish and how it's similar to the anglerfish and how it uses this shiny thing to attract stupid fish. Here's something I didn't know though. If you go to Google Images and type in say bioluminescent fish, you should notice something. Most if not all you see is mostly blue, green, or a combination of the two. In the deep ocean, fish are very sensitive to blue, and most fish can't or can hardly see red. This is for a number of reasons that I will not go into right now. Anyway, some species of dragonfish also emit red light that other fish can't see, making an effective flashlight an invaluable tool for hunting. It's almost like being in a dark room, somebody shining a flashlight on you, but only the person holding it can see it, which is absolutely insane, I think. The dragonfish shine the light on the unaware fish, and the red light reflects back at him. This is used for bioluminescence similar to countershading, counterillumination. For this example, I shall use the cookie cutter shark. They use bioluminescence to illuminate themselves the same color as their background. However, do you see that dark spot right there? This makes it look like a smaller fish to slightly larger predators. So the larger fish come along, think they're going to get an easy meal, but they're really in for a surprise. Next one, I will have to explain an example of a situation. There's a fish swimming around minding its own business, probably looking for something shiny. Then suddenly a big fish appears and is about to attack. The small fish starts flashing to be noticed by an even bigger fish that eats the big fish but not the small fish, and the small fish escapes. And as a final example, communication. This one was especially mind-blowing to me because we know so little about it. Experiments have been done where scientists put false bioluminescent machines in deep water to give off different patterns and strobes. And the fish respond to them, and respond differently to each pattern. This isn't coincidence either. The fish time it perfectly, only flashing after the machine does. So far we have discussed the basic formula of what causes bioluminescence, a few examples of the fish that do, focus on a single zone of the ocean, where more than 90% of the fish actually do emit bioluminescence of some sort, and we know they somehow communicate with it. The sheer complexity of this one aspect of the ocean is absolutely mind-blowing. It's a multi-minute video and wasted no time and space in there where information could have been. A single subject focused on a single zone in the ocean, based on incomplete information of nascent research of an area that we are just starting to wrap our heads around. We're at the bottom of the ocean, but we've merely scratched the surface.